We can identify atoms by a chemical symbol, like hydrogen is given the symbol H, carbon is given the symbol C, oxygen the symbol O, etc. These are listed on the periodic table. And then, since the neutrons and protons are about the same mass, we set them equal in mass to 3 significant figures, and we have a special set of units called atomic mass units. And in these special units, the mass of the proton is equal to 1 AMU. Mass of a neutron is equal to 1 AMU. And the mass of an electron is very small, so we don't concern ourselves with it for the mass of the atom. So we symbolically write an atom, say carbon. We would write the number of protons as a subscript, and we write the number of protons plus neutrons as a superscript. So the carbon-12 isotope would have this symbol. That means that we have 6 protons, and we have 6 protons plus 6 neutrons in the nucleus. Carbon-13 would have the symbol like this, and carbon-14 would have the symbol this. A quick shorthand way of identifying the element and the number of neutrons present in the nucleus for the various isotopes. Now, if we were to add the masses of each atom in atomic mass units, carbon-12 would weigh 12 atomic mass units. Carbon-13 would weigh 13 atomic mass units. And if we wanted to find the average weight of naturally occurring carbon, because it occurs as a combination of these 2 isotopes, so we could take the abundance, the fraction of each isotope that exists in nature, and get an average weight. And so to do this, we could have the atomic mass as an average is equal to the sum of the fraction of isotope I times the AMU, atomic mass unit of isotope I. And we sum over all of the isotopes. So let's consider the carbon-12 and 13 isotopes. We look up in a table and we find that carbon-12 has an abundance of 0.9893. So that just means that 98.93% of all carbon you dig out of the ground or find is carbon-12. And carbon-13 has an abundance of 0.0107. So about 1.07% of carbon existing in the Earth would exist as carbon-13 isotope. So the average mass would equal to 0.9893, the abundance, times 12 AMU plus 0.0107, the abundance of carbon-13, times its mass, 13 AMU, and that would equal 12.01 AMU. So that would be the average atomic mass for carbon.